one of them is they are representing the high ground in space exploration, because from these places you can go not only to the moon but to other places as well. You can go to the lunar surface from there. You can also go to asteroids, and you can go to Mars. And this is already part of the challenge to you to exploit this nice spot, to exploit the fact that you can use it as high ground for human endeavor into outer space. Another very important reason why the moon is this document, and even if you want, you can Google it, the Global Exploration Roadmap. The Global Exploration Roadmap is a document that summarizes the common view of global space agencies, of international space agencies that are member of the International Space Exploration Coordination Group, ISEC-G, and it was released in 2013 and is a very interesting read. It's publicly available, so if you download it and read it, it will be a very interesting basis of your work in the frame of this challenge. Now, we call it the GER, Global Exploration Roadmap, identifies the moon as a very important intermediate step to further exploration as well. So not only is there a physical reason, meaning this high ground from which we can explore all the rest of the solar system, but there's also a programmatic international agreement that this very special place nearby, called cislunar space, is an important step on the way to future space exploration. So now you may ask, what's in it for me? And I understand that is a very, very valid question. And that's always what I'm asking, what's in it for me? Well, eternal glory. And that's important. Absolutely. I'm absolutely with you. Anything you do must also be a benefit to yourself. And of course, if you are successful in a challenge like that, that gives you already a lot of knowledge, a lot of contacts, all these things that you will use in your future careers to make things happen. And we really sincerely hope that these things that you will make happen are somehow related to space. And there will be a surprise. We'll not spoil it today. Basically, the three forerunners teams will be invited to the symposium Moon 2020-2030 that takes place in December 15th and 16th of December this year here at ESA to present their concept. So all three forerunners will present their concept, and there will be a first, second, and third prize. And we will then, in due time, as we are ready to open the box, we will then present the prizes. So what will we talk about today? I mean, today is very important for the challenge because it sets the stage for what the teams will do, the international teams. So we will talk about why we are here today, which is always important so people don't think they would waste their time. We also would like you to understand what we do expect in terms of input to our challenge. It's very important because we have certain expectations. What is the playing field? In each challenge, in each contest, there must be a playing field that must be fair. So certainly we would explain that before. Then we explain a moon mission. And you will see that is one example, and it gives you already a framework to work in, so you don't have to start really from scratch. You may decide to start from scratch still if you think that you have a great idea that you want to communicate. So it is an example rather than a constraint. And then what's next? So what are the next steps for you to get involved and kickstart the challenge for you, your work with your team, and so on. So today is really for ESA, for us, for Josette and myself to give you all the details that you need. And if we do miss anything, and we've tried to be complete, but if we do miss anything and you have further questions, then we mean this is not a one-way process, but a two-way. So please get back to us via email, via Twitter right now, via the channels that I will list later as well again. If you have any open questions, then please don't be shy and let us know. So what do we expect? The contest submissions and products should be the following. We're looking for a mission scenario, whatever you think that is. We don't, at this stage, prescribe two specific items here. What we want to see in that mission scenario, though, is a timeline, a list of elements that would kind of operate in this timeline, an implementation plan, and an idea or a description of how you would your team see an implementation of that. Say if you have a team, 3 from Scotland, 2 from Japan, and another 2 from Russia, another 2 from the US. And then it would be a good idea to kind of explain how the US was contributing, how Russia was contributing, how Scotland contributed. Excuse my politically incorrect relation. So that's the idea. Try to put together not only technology, but also how your country can work together to make this happen. The next step is an operational concept that includes the overall principles, so safety, efficiency, sustainability, these overarching principles. A description what the elements that you defined in part 1 should do, and the interfaces between these elements, very important. Could everybody please mute? The international nature of this, where you want to also understand how the interfaces between your space agencies should work. The third product we would like is a simulation that helps us to communicate your concept. So we want an illustration in the form of a video or a picture or a PowerPoint or any of the products that are mentioned on the poster and on the various channels. So an illustration that helps us to communicate your idea, because at some point we are very much interested to communicate your ideas, to show what bright ideas are that are coming out of our contest and your contest. This can be on the lunar surface, or it could also be in this cislunar space. Both. It doesn't need to be all of it, so end to end. If you have one aspect of this mission architecture is very intriguing, and you think that is worth communicating, then that is the one that you should focus on. And we would like also to have a poster in which you summarize your findings. So that can be any format, but we would like to also show, again, that for us to communicate your ideas, we want to show that the symposium, the various ideas that we will then select. Okay, so what are the constraints of the content? And these constraints are really borderline rules that we should adhere to in the content. So the mission scenario must define roles for humans and robots to work together or work, in their roles. So there should be a definition what humans do and what robots do. We expect credible technology of the early 2020s. So no beaming, no, I don't know. There are funny movies out there, like Iron Sky. Who knows Iron Sky here in the audience? The movie Iron Sky. Okay, so they make moon travel with 1940s technology. Nothing of that. We want real technology that you can expect to be there in 10 years' time. The number of surface missions should be between 2 and 4. And there is some creativity asked for here, but however, at least you should have an idea that there's a repetitive way to go to the lunar surface, and it should be in the range between 2 and 4, not 20, not 1. So now comes something that I will explain later. There is a mission architecture scenario already. It's called Heracles, and that will act as an example, not necessarily as a constraint. So we'll have a scenario that I will explain in a minute, and please don't copy that. We're not into copying. Okay, so what are the rules besides the constraints? All reference must be documented in a reference list, so we don't want to have people showing up later and say that's from us, not from that team. It would be great if you can always, if you use other people's work, please reference it. The technical report describing the products that I mentioned before should be 30 pages, including the cover page and excluding the reference list and the appendix. And very important rule, each team must consist of members from at least 2 continents. The continents are these big lumps of mass on planet Earth, right? I don't accept any other interpretation of the word continent. There's a question right here. That's a good point. The question was why? Why do we require this? The idea is that ESA views space exploration as a global endeavor. And it's really difficult to get that defined in any other way clearly and easily. So if you require 2 continents, at least, members from 2 continents, then that should give the whole thing at least some kind of global cooperation. And the continents are defined on Wikipedia if you need to, because there's Europe and Asia is, from a geology point of view, really one continent. So, Grant? We're not talking about national passport. We're talking about people who live and work there. Okay? Yeah. Or Shazad, do you want to add something to that? Did I get that one? It's right. Okay, thank you. Okay, let's talk about Heracles. So the word Heracles has been mentioned before. So what really is it? Heracles is a architecture that comprises of elements, and these are international elements, and they're all kinds of elements, not only technology, but also other entities like astronauts, robots, vehicles, and control centers. They're elements that work together to serve a purpose and to solve a certain problem of lunar exploration. Heracles has a mission statement which tries to summarize all the objectives of Heracles. And I will read it to you because it's kind of our mantra that we always use in the project. So Heracles is to establish key elements and capabilities for sustainable human exploration of the Moon and human robotic exploration of Mars by implementing lunar surface operations while maximizing opportunities for unprecedented scientific knowledge gain. A lot of text there, a lot of big words, but that's what it boils down to. So really we want to prepare human exploration of the Moon. We want to contribute to human robotic exploration of Mars, and we want to open a door for future great discoveries in science. When is it going to happen? If you check out the Global Exploration Roadmap, you will find a period in the mid-2020s in which there's an opportunity to use the cislunar infrastructure to have a mission architecture like that. So that's the typical time frame we're talking about. And here is an example of a mission scenario, which is Heracles, and that should give you an idea of what we are expecting. Again, Please don't copy it one-to-one. You could choose to focus on one of these phases and make that a little bit more visible and understandable using your ideas. So in that sense, that would not be copying. But if you just use my slide and then send it in, you probably not get a good response. So what we are looking at is a launch of multiple elements. So we're assuming having a small station there, habitation module, available in cislunar space. It's labeled EML2 for Earth Moon Libration Point 2 at this stage. It's on the far side of the moon, seen from Earth. And there are two launches. One is the ascent stage and one is the descent stage, both of which get assembled and then descend to the lunar surface. On the lunar surface, we see a rover deployed from that landing vehicle, and it is initially ground controlled, but at some stage we get a human launch with a human vehicle going to the same station, and then the humans are in a position to teleoperate this rover on the far side of the moon. This rover takes samples and brings the samples to the ascent stage with the crew still being there at the station. Then the ascent stage takes off into low lunar orbit, goes back to the station. The samples are transferred into the human vehicle. Human vehicle comes back home, and the rover stays on the lunar surface, and the station stays there with the ascent stage attached. So both the rover and the ascent stage can be reused. In the next stage, you can launch again a descent stage. Descent stage docks to the ascent stage again, and then has another opportunity to go down on the second mission to the lunar surface, and so on, and so on, and so on. So you can do that 2 times, 3 times, 4 times. So this is the architecture that we're talking about. What are the elements of Heracles? Heracles has the ascent stage, lunar ascent element, has the lunar descent element, a descent stage, a surface mobility element, SME, the rover. It has a in-space sample preservation element, which is the sample container. It has a service module. We also refer to that as the space tug. And it has exterior elements, other services provided by the station. Now, this station sometimes is called EDSH for Evolvable Deep Space Habitat, and it will be a word you find also in the Global Exploration Roadmap. So this is a piece of infrastructure that is foreseen to be there in any case, independent of the Heracles architecture. And it has some functionality. It has a robot arm to assemble the vehicle, for example. Of course, we're talking about the moon, so you have to know your way around on the moon. What's on the moon? I understand that not every student today, there's a question up there. Right. So the question is if the surface missions need to be human or non-human. It's your choice. You can have both are possible, and there are different requirements for the two. And here it comes a very important question: is what are the roles of humans? What can do humans best? And what is the unique value of humans on the surface? What's the unique value of humans in orbit? And on the other hand, what's the unique? What are robots good in doing? And so that's for you to figure out. So getting your way around on the moon is not that straightforward because the lunar geology is not as intuitive as on Earth. There are no rivers, there are no streets, there are no oceans. It's mainly craters, volcanoes, and regoliths. Now, what I'm showing here is a nice map provided by or that you can get that from the internet, but it's also available, a nice poster from the National Geographic showing the moon with all its features, astrophysical features as well as the surface itself. Now, that's a good way. Actually, that's the poster I have in my office. If I have to find my way on the moon, that's where I go. But there's even much better way, which I understand is more modern, is to use the web. And there's a URL here that provides you with data from the latest survey mission around the moon, the LRO, NASA mission. And that's been made available by the University of Arizona State on this URL. And it's really a global view of the moon with all features. And I encourage everybody to go there and find intriguing places or search on the web for things that are exciting about the moon. Just to give you an example, the people talking about a good way to look for extraterrestrial artifacts would be the moon. Because if extraterrestrials were here 100,000 years ago, and they put something here, you would not find it on Earth. On the moon, anything that's 100,000 years old looks like brand new. So that would be an exciting story. Perhaps a bit science fiction now, but it's inspiring, and we're not looking for a future science plan. We're looking for inspirational content for future moon architecture. Okay, so this is how you get your way around on the moon, and you have to find your way into what's a cylindrographic coordinate, how is the moon, what are the coordinates on the moon? You need to find your bearings. That's something I trust you can find out yourself. And so to support you a little bit on, get you started on what to find on the web, here are the things that you could Google or you can wiki. So a couple of keywords, I'm not reading them to you. This is something, if you enter it into any of these search engines, then you get a good start on this. Okay, so what are next steps? The next steps is that we would like you to send a letter of intent, and I understand the form for that will be online pretty soon. It's not online yet. Will be online pretty soon. And we would like to ask you to deliver your input by the 2nd of November. So there's some time from today until November 2nd. And then we will nominate the forerunners by November 16, and then the forerunners will also have to make some travel arrangements to come here to ESTEC. And the symposium, where then the presentations will take place 15th, 16th of December this year. Okay, so I've explained to you some things on Heracles. In order to set the stage also in terms of expectations, I'm showing you a couple of illustrations of the operation of the Heracles architecture, so you understand the level of quality that we expect. So this is a visualization of the surface element of Heracles as it is designed in a design study around here. And there's all kinds of interesting information on how to design spacecraft, and I also rely on your knowledge that you already acquired in your studies. What is a spacecraft, how to design it, how can it be operated, and all these very important aspects. And the tools that you might use, like for example the Kerbal Space Program platform, will give you some ideas of how to assemble vehicles, how to build them, and that will also help you to put together illustrations like that. So that would be the surface operations, and then we have the orbital operations. One example how the vehicle gets assembled. It's now a different vehicle. Also to show you a bit, we are not really hooked up to one possibility here. We're talking about just illustrating how that could look like, with the surface vehicle then being detached from the station and flying away back, actually in that case, to the moon. It's also a nice illustration because it shows, as you can see from the Earth-Moon libration point, the Moon is about twice the size of the Earth, just because you're much closer to the Moon, about 60,000 kilometers, compared to around 400,000 kilometers to the Earth. Okay, so before I come to the final part, I would like to share with you a couple of recommendations to increase your chances of success. So in terms of forming the team, and that relates also to the question we had in the room before, I would like to ask you to be creative. Try not to sneak your way out of the rule by making somebody going on vacation to Russia and then claim he's working in Russia, right? That's not the idea. The idea is really to be creative and try to engage in the idea that we're talking about global space exploration here. So that there are two examples here that I use. I didn't put Scotland here, but you can see the other nations. So if your team is more than 10 strong, we would like to know. There's no exclusion criteria or anything. We just need to know for the logistics point of view. The role human and robot is very important. That's something very close to our heart here at ESA, simply because there's been a misunderstanding in the past that led to the idea that robots will replace humans, which is absolutely not possible. It will never be possible simply because robots are not humans. The other misunderstanding is that humans can do everything robots can. That's also not true. So we would like to advance our understanding of how humans and robots, or how humans can use robots to achieve the important goals that we are talking about. And that is really should be at the heart of your contribution. There's a lot to design here. There's vehicles, there's things. Don't get lost in the amount of it. If you feel that if you have only a 3-person team and you feel that there's too much work to be done, focus on something. Find something in this whole story that is so inspiring that you want to share with everybody. Focus on a human-controlled robot digging up an alien artifact on the moon, if that's your theme, or digging up the stone that has recorded information of the geology of the solar system and all terrestrial planets, stuff like that. Right. Then I would like you to also to give you a recommendation. Look into yourself. What is your expectation of space exploration in the 2020s? So what do you think, where should the world be in mid-2020? Should we be exploring the moon, Mars, and so on? Or should we perhaps explore the deep ocean? Well, that doesn't work for our challenge, right? So, but what should we do on the moon? Should we stay on the moon? Or should we use the moon as a stepping stone? Or is that, what's your vision? What is your liking? Would you be an astronaut? Would you be a control center manager? Would you be a programmatic person putting together the program? Would you be a politician? So what's your personal link? What's your engagement here? And the final word in terms of recommendations, quality, quality, quality. So there's only 3 things that are important, right? Quality, quality, quality. It's like in my flight training. When I was flight training, my instructor said, there's only 3 things that are important: altitude, altitude, altitude. So I did all this training, and next day I came to the next lesson, and I was precise on altitude. And then he said, there are only 3 things that are important: heading, heading, heading. So that's difficult. I understand. You always have to weigh quality for the time you have and the other constraints. But in whatever you do, try to maximize quality. Right. So these are the links and contact info. You can read that yourself. So you can always be in touch with us, with Shahzad, with myself, with the people that help us implementing this. And this brings me to the questions. Thank you.